A dry riverbed in northern Kenya, a wrong turn down a dead-end gully, a team of archaeologists who weren't even looking for this, and a pile of broken stone that, for 50 years, textbooks insisted could not exist. Tools older than the human genus itself, older than the name Homo, older, in fact, than the very cognitive leap scientists use to define what makes something human in the first place. And somewhere in that dust, next to fossils of animals long extinct, sits a question that still doesn't have a clean answer. If these tools weren't made by us, or by anything that would eventually become us, then who broke these stones on purpose? 3,300,000 years ago? Every field has a founding myth, a story it tells about its own beginning, and for a long time, paleoanthropology's founding myth was almost sacred. It went like this. Somewhere around 2.6 million years ago, a bigger-brained ancestor finally crossed a threshold, picked up a rock, and changed everything. That single moment was supposed to be the hinge the entire human story swung on. What if that hinge is in the wrong place? What if it always was? This isn't fringe speculation. It's published, peer-reviewed science that ran through the same review process as every major discovery in the field, and it appeared in one of the most rigorously scrutinized journals in the world, Nature, in May of 2015. The lead author was Sonia Harmond, an archaeologist at Stony Brook University's Turkana Basin Institute, working alongside her husband and fellow researcher Jason Lewis as co-director of the West Turkana Archaeological Project. This wasn't a solo claim from an outsider chasing headlines. It was a team excavation, radiometrically and stratigraphically dated, cross-checked by geologists studying the volcanic ash layers. The tools were buried in, and it survived the scrutiny of a scientific community that is, frankly, not easy to impress. That scrutiny matters, because a claim this big doesn't get a free pass just because it's dramatic. In the years after publication, other researchers pushed back on parts of the interpretation, questioning whether every single one of the 149 recovered pieces was truly the result of deliberate, purposeful napping, or whether some could be explained by natural rockfall and trampling. That kind of pushback isn't a scandal, it's how the field is supposed to work. And even with that healthy skepticism folded in, the core finding that intentional, humanly worked stone tools exist at 3.3 million years old in clear association with hominin fossils has held up through nearly a decade of continued excavation, reanalysis, and follow-up fieldwork at the site. Here's a way to picture how they know the age. Imagine a layer cake, except every layer isn't frosting. It's a different volcanic eruption, each one leaving a thin, chemically distinct sheet of ash across the landscape. Geologists can identify each of those ash layers almost like a barcode, because volcanic eruptions leave a specific chemical signature that can be matched to eruptions dated elsewhere with extreme precision. The tools at this site were sandwiched between two of those ash layers, meaning their age wasn't a guess, it was bracketed from both sides. And for the single number that matters most in this whole story, it's worth sitting with it twice. Picture the Grand Canyon, which took roughly 5 to 6 million years to carve. These tools are more than half that old. Now picture it a different way. If all of recorded human history, every pyramid, every empire, every war, every book ever written, took up 1 minute on a clock, the gap between these tools and the invention of writing would stretch back almost 9 hours before that minute even started. 3,300,000 years. That is not ancient. That is almost incomprehensible. Now here's the part that connects everything and explains why this discovery landed like a shockwave. For decades, the working theory in paleoanthropology was airtight, or at least it seemed that way. Tool making was supposed to be the marker, the dividing line, the thing that separated the genus Homo from everything that came before it. Bigger brains, dexterous hands, the capacity for abstract planning, all of it was packaged together into a single evolutionary story. Climate changed, forests thinned into grassland. Our ancestors had to adapt fast, and out of that pressure came Homo habilis, literally handyman, the first toolmaker, roughly 2.6 million years ago. That was the story in nearly every textbook. Clean, linear, convenient. It was also, as it turns out, built on an assumption nobody had seriously tested, because nobody had gone looking hard enough in the layers old enough to challenge it. When Louis Leakey and his colleagues first uncovered stone tools alongside early human fossils at Oldowan Gorge in Tanzania more than 50 years ago, that discovery, dated to around 1.8 million years, became the anchor for everything that followed. It set the boundary. It told an entire generation of researchers where to stop digging, because why would you look for tools in sediment older than the thing you'd already decided was the first toolmaker? Lomekwi only exists in the scientific record because a team was willing to keep looking anyway, even after taking a wrong turn into a place they weren't planning to be. Sonia Harmond didn't set out to break that story. In July of 2011, she was simply driving her Jeep through a dry, eroded landscape near Lomekwi, close to the shores of Lake Turkana, when she and her team took a wrong turn and ended up in an unplanned dead-end gully. Instead of turning back, they got out and looked around. What they found scattered across the eroded surface were stones that didn't look natural. They looked struck, deliberately, repeatedly struck, in a pattern that doesn't happen by accident, wind, or water. Over the following field seasons, excavation at what became known as Lomekwi III recovered 149 stone artifacts in total, including cores, flakes, and unusually large hammerstones, some weighing up to 30 pounds, alongside fossils from the same sediment layer. If you're picturing a delicate hand axe, don't. These are big, blunt, and clearly the product of somebody who understood, even in a primitive way, how stone fractures when struck at a particular angle with a particular force. That understanding didn't happen by chance either. Here's the part that changes everything. The team gave this technology its own name, separate from anything that came before, calling it the Lomekwian industry, and it predates the previously oldest known stone tool tradition, the Oldowan, by roughly 700,000 years. Take a second with that. 700,000 years earlier than what scientists had spent decades treating as the beginning. That's not a footnote. That's a new opening chapter inserted before what everyone thought was page 1. It's also worth understanding, briefly, how these particular stones were actually made, because the method itself is part of the evidence. Harmon's team ran controlled experiments trying to reproduce the exact style of fracturing seen on the Lomekwi pieces. What they found was that this wasn't the same precise one hand holds the core, one hand strikes with a hammerstone technique used later in the Oldowan tradition. It looked more primitive than that, more improvised, consistent with methods like bipolar percussion, where a stone is placed on a fixed rock anvil and struck from above, almost like cracking a nut between two surfaces rather than carving with precision. That detail matters because it paints a picture of toolmakers who were still, in a sense, figuring it out. Not masters of the craft, beginners. And beginners, by definition, had to start somewhere even more primitive than this. So who made them? This is where the story gets genuinely strange, because the honest answer is that nobody knows for certain, and it's worth sitting with that instead of rushing past it. What we do know is the timing. 3.3 million years ago places these tools squarely in the era of Australopithecus afarensis, the same species as the famous fossil Lucy, a small-brained, partially bipedal hominin that most scientists, until this discovery, would never have credited with intentional toolmaking. But the plot has another layer. Fossils belonging to a different, less famous hominin, Paranthropus plateops, have also been recovered from deposits in the same general region and time window, first described by paleoanthropologist Meave, Leakey's team years before Lomekwi III was ever found. Neither species has been caught, so to speak, with a tool actually in hand. No skeleton was found gripping a hammerstone. What existed is a temporal and geographic overlap, hominin fossils and stone tools sharing the same sedimentary neighborhood at the same rough moment in time. That's a real, meaningful clue. It is not, on its own, a signed confession. Think about what that actually means for the shape of our family tree. For most of the 20th century, human evolution got taught almost like a straight line, one species quietly replacing the next in an orderly march toward us. Lomekwi is one more piece of evidence for something the fossil record has been hinting at for years, that the truth looked more like a crowded branching bush with multiple hominin species alive at the same time, in the same region, possibly even competing for the same resources. Lucy's species wasn't alone out there. Paranthropus plateops wasn't alone either, and if intentional toolmaking existed in that world, there's no guarantee it belonged to just one branch of that bush. It might have belonged to several, independently, or it might have spread between them the way a good idea spreads between neighbors. Before we go further, quick pause. If a discovery like this is the kind of thing that genuinely rewires how you think about your own species' story, that's exactly the kind of thing this channel exists to dig into. So if you haven't already, now's a good moment to hit subscribe, because it only gets stranger from here. Let's recap where we are, because the next part builds directly on it. Stone tools, deliberately made, dated to 3.3 million years ago. That's 700,000 years before the tradition scientists spent decades treating as humanity's technological starting line. The makers were almost certainly not Homo, because Homo, as far as the fossil record shows, didn't exist yet. That single fact forces a re-examination of everything we assumed about what triggered tool-making in the first place, because it clearly wasn't a bigger Homo brain reacting to a changing climate. Something else, something in a smaller-brained, more primitive hominin, was already capable of it. In the next part of this, we go straight into how this connects to a second, independent piece of evidence that had already been quietly hinting at the same conclusion years before Lomekwi was even found. Rewind slightly to Dakika, Ethiopia, a different site entirely, roughly 3.39 million years old, dated even earlier than Lomekwi. There, researchers led by paleoanthropologist Zerasene Alamseged recovered animal bones bearing marks that appeared consistent with intentional cutting and percussion, the kind of damage you'd expect if someone were using a sharp-edged stone to strip meat from a carcass or crack it open for marrow. Here's where it gets interesting. No stone tools were actually found at Dikika. Alongside those bones, just the marks themselves, interpreted as evidence that something, or someone, was already using sharp stone edges on animal remains even before the Lomekwi toolmakers left their own evidence behind. 2 separate sites, 2 separate teams, working independently, both pointing in the same direction, toward tool use well before the accepted 2.6 million year mark for the Oldowan. That's what scientists call triangulation. And it's a big part of why the Lomekwi find held up under scrutiny instead of being dismissed as an anomaly. What makes triangulation so powerful in a field like this one is that any single discovery on its own is vulnerable. A single site can be explained away as a fluke, a misreading of the geology, a one-off. But when independent teams working hundreds of kilometers apart, using different dating methods and different lines of evidence, keep arriving at roughly the same conclusion, the odds that it's all coincidence start to collapse. Dikika suggested it first, in a quieter, more contested way. Lomekwi confirmed it with something far harder to argue with, the actual tools themselves, not just the marks they left behind. If this is the kind of story where the accepted timeline just keeps sliding further back, the harder people look, that's worth sticking around for. So if you're enjoying where this is headed, this is a good point to hit that subscribe button before we go even deeper. And the story didn't stop there either. In 2023, an international team led by Queen's College anthropologist Tom Plummer published findings from a site called Nyayanga, overlooking Lake Victoria in Kenya. There, researchers recovered Oldowan-style tools, cores, pounding stones, sharp flakes, dated to somewhere between 2.6 and 2.9 million years old, among the oldest examples of that specific tradition ever found. What makes Nyayanga so relevant to this story is what was found near the tools, not Homo fossils, but a tooth belonging to Paranthropus, a heavily built, robust hominin lineage, long assumed to be an evolutionary side branch, not a toolmaker. Microscopic wear analysis on the tools themselves suggested they'd been used for a whole range of tasks, butchering animals, cutting plant material, pounding tubers, even possibly working wood. The team even found the remains of 2 hippos at the site, with cut marks consistent with butchery, right alongside the stone cores that could have made those marks. Think about what Paranthropus represents in this story. For most of the last century, Paranthropus was treated almost dismissively in the textbooks, a heavily built, small-brained cousin of our lineage that chewed tough plants with massive jaw muscles, and eventually went extinct without leaving descendants. It was cast as evolution's dead end, the branch that didn't make it. And yet, here it is, potentially standing right next to some of the same Oldowan technology, once credited exclusively to our own genus. Put Lomekwi, Dikika, and Nyayanga side by side, and a pattern starts to emerge that no single site could prove on its own. Toolmaking wasn't a one-time cognitive leap that belonged exclusively to our genus. It looks increasingly like something that multiple, only distantly related hominin lineages were capable of, independently, long before Homo walked onto the scene at all, and possibly even after Homo arrived, running in parallel rather than in a single unbroken line. There's also a question worth sitting with here, because it cuts against the tidy version of the story most of us grew up with. If toolmaking wasn't the invention of smart hominins reacting cleverly to a changing world, if instead it emerged multiple times in multiple lineages, some of them small-brained and never destined to become us, then the old idea that technology is what makes humans special starts to look a lot shakier. Maybe it wasn't a spark unique to our branch of the family tree. Maybe it was closer to something latent in the broader hominin toolkit, waiting for the right combination of hands, stone, and need to bring it out in more than one species, more than once. Now, here's the part that has to be said plainly, because this channel isn't in the business of overselling a story past what the evidence actually supports. What is not proven, and what nobody serious in this field is claiming, is that scientists have identified the exact individual, or even the exact species, that made the Lomekwi tools. No hominin skeleton has ever been recovered clutching one of these stones. The link between the Lomekwi tools and any specific species, whether Australopithecus afarensis or Kenyanthropus platyops, is based on temporal and geographic association, not direct individual level proof. That distinction matters, and it's one worth being precise about rather than blurring for the sake of a tidier story. Population level and site level evidence, fossils and tools sharing the same layer of sediment in the same region during the same narrow window of time is genuinely strong and scientifically meaningful. But it is not the same as catching a specific hominin in the act, the way DNA from a single skeleton can sometimes tie a discovery to one named individual in far more recent archaeology. Here, at this depth in time, that kind of individual-level certainty simply isn't available, and pretending otherwise would be dishonest. To be clear, the Dikika bone marks carry their own layer of honest uncertainty too. Some researchers in the years since have raised the possibility that at least some of those marks could have resulted from trampling or other natural processes rather than deliberate cutting, and that debate hasn't been fully settled either. Even at Lomekwi itself, as mentioned earlier, not every one of the 149 recovered pieces is universally accepted as unambiguous evidence of intentional napping by every researcher in the field. Good science means holding on to that uncertainty rather than smoothing it over for the sake of a cleaner story. Nobody is claiming a finished picture here. What exists is a strong, converging body of evidence, gathered by multiple independent teams, pointing consistently in the same direction, and a genuine, still open question about exactly who was standing there, stone in hand, 3.3 million years ago. And maybe that's the part worth sitting with longest. For most of the history of this field, the question was always, when did we become clever enough to make tools? That question assumed the answer had to be about us, specifically, about the branch of the family tree that eventually became Homo sapiens. But the stones at Lomekwi don't care about that framing. They were struck deliberately by hands that would never write a word, never build a fire we know of, never leave behind anything else recognizable as culture, and yet somehow understood the physics of a well-aimed strike on a rock well enough to do it again and again. There's something almost humbling in that if you let it sit for a moment. We tend to tell our origin story as though intelligence and ingenuity arrived in one clean package, bundled together with our own genus, ready, made. What Lomekwi suggests instead is messier and in a way more honest. That the raw ingredients of technology, of problem solving, of looking at a rock and seeing a tool inside it, existed in the world long before anything resembling us did, scattered across branches of the family tree that never survived to tell their own story. If you go back to that dry gully near Lake Turkana, to the wrong turn that led a team of scientists to a discovery nobody was expecting, the honest takeaway isn't a neat answer. It's a reminder that the beginning of the human story keeps getting pushed further back every time someone is willing to look a little closer at the ground beneath their feet. If you've made it this far, don't forget to like this video. It genuinely helps this kind of story reach more people who'd want to see it too. And before you go, tell me in the comments which part actually got to you more, the fact that these tools predate the human genus entirely, or the fact that after all these years, scientists still can't say for certain whose hands made them.